Hello, I welcome you all in this course on materials processing, fundamentals and practical. So, this is the first lecture which is about the overview of the material processing. This includes about the materials and where from the different materials we obtain, important characteristics and the role of material processing in the manufacturing scheme, and then what are the modern trends in material processing like sustainable manufacturing, additive manufacturing and the green manufacturing. So here the content of the presentation includes like overview, definition and scope of the material processing, development of the material processing, classification of the materials, modern materials processing, manufacturing and production comparison. So, this is what we can see as far as the material processing is concerned, where the material processing exists. So, say this is our earth, and from the earth what we do through the mining, drilling with beneficiation, we try to extract the material. So by mining, drilling and extraction, raw material in form of ores, crude oil, gases etc are extracted, and then through the thermal processes, mechanical and chemical processes, the minerals, ores, gases, oil etc are processed to get the starting material. So this starting material may be in form of the metals, in form of ceramic materials or polymers. Okay, these are the three broad categories of the materials which are processed to make the variety of products. So the metal in form of slabs, and the ceramic materials in form of powders, and the polymers in the form of pellets. These starting materials are then processed, involving the material processing. So starting material is subjected to the material processing to get the desired shape of the product coupled with the desired set of properties, which is realized through the proper control of the structure of the material. Okay, so the products made are then further used for making the usable components, usable products like assemblies. So the individual components made through the material processing are subjected to the assembly, okay, so that we get the usable products. These products are used by the consumers, and once the product has completed its life, it will be as a waste. So this waste can be used in different ways. For example, the waste material can be reused, and for reusing it can be processed again to make the components and products. It can be recycled and used as a starting material, or during the material processing, if we get the defective products or rejected items, then these are again recycled or reprocessed for remelted and reused, okay, for making the starting material. And the something which is not used for anything like reuse, recycling, then it will be disposed of and it will not be used further as a waste. So material processing basically involves the transformation of the raw material into the finished products through the various techniques. So this finished product is basically an intermediate item which may be further processed or which may be given further treatments. Okay, it can be subjected to like assembly with the other components to make the usable products. So basically it involves the transformation of the raw material into the finished products, and this transformation is realized through the use of mechanical, thermal and chemical processes to get the product of the desired shape and product with the desired structure. okay, so that the desired set of the properties for given performance of the product during the service are realized. Okay. Material processing involves a complex series of chemical, thermal and physical processes that helps in preparing the starting material, followed by creating the product of desired size and shape and coupled with the desired properties and structure. So, this is what is done basically in material processing. It may involve variety of chemical, thermal and physical processes to convert the raw material into the desired product, which is having the suitable structure and combination of the properties for expected performance of the product during the service. The goal of the material processing is to develop the structural features such as crystal structure, microstructure, geometrical features as per the requirement of the product. So, material processing not only involves the obtaining desired size and shape of the component, but also focuses on realizing the desired structural features, so that suitable combination of the properties in the product can be imparted for desired performance and the life of the component. So, here material processing is in the central to the field of material science and engineering, because this forms the material processing forms the basis for realizing the desired structure and properties, and that is why it plays a vital role in manufacturing. Conversion of the starting material to the final product occurs in material processing through three stages. One is preparation of the starting material, where the suitable changes in the raw material are brought in. Second is the processing of operation, which will be converting the starting material into the desired size and shape, followed by the post processing operations, which will involve the further treatments and steps to impart the desired qualities in terms of surface finish, dimensional tolerance, desired microstructure and mechanical properties. Additionally, in the material processing, three types of the materials commonly used. These are metals, ceramics and polymers. Okay, and these materials are processed using suitable combinations of steps to obtain the desired structure and properties of the component. So, depending upon the type of material which is being processed, whether it is metal, ceramic or polymer, we choose suitable kind of the process for material processing, so that or combination of the processes, so that the desired structure is realized to obtain the product of the desired characteristics. Material processing is critical in manufacturing, as it determines the characteristics and performance of the product, and this is based on the control of the desired structure of the product which is being made. So, this control over the structure of the product helps in realizing the desired characteristics and performance of the final product. Okay. So, when the material processing is done by controlling the desired structure and properties of the product which is being made, so that the product meets the specification and the standard requirement related with the particular application. So, basically the material processing helps in dictating or determining the characteristics and performance of the product, and it also helps in making the product which can satisfy the requirement of a particular application and the requirement of the standard. Material and the properties are actually in the core of the material processing, since we have to deal with the variety of materials. So, we need to see really how the desired structure in variety of materials can be realized to obtain the desired set of the properties. So, material processing is the series of the steps that converts the starting material into a useful form with the controlled structural features and properties. This is in the core, okay, not just a shaping, but also realizing the desired structural features and the properties in the component. As far as the key fundamentals related with the material processing is concerned, it involves like the material properties which are there in the beginning, and the kind of the phase transformation which will be happening when it is subjected to the material processing through the application of the deformation, heat or compositional modification, and also it involves the understanding the relationship between the processing conditions and the material structure and the behavior of the material that will be happening during the processing. And also it is important to understand that how the structural variation will regulate the properties of a given material. Since we are dealing with the variety of the materials like different types of the metals, the polymers, ceramics, or even the mixture of these in form of composites. So, the how the structure of a particular kind of the material is affecting the properties, understanding of that is also important in designing the suitable material processing approach, so that at the end of the processing we are able to realize the desired set of the microstructural features, structural features and the properties to get and realize the desired performance. So, study of the material properties, the kind of phase transformation that will be happening during the processing, understanding the relationship between the processing condition and material behavior or response of the material, and understanding the structure and property relationship. These are the key things as far as the material processing is concerned. Then now we will see how the things have evolved in material processing. So, in the early stages material processing techniques included smelting of the smelting for metal extraction. So, this involved basically obtaining the desired metallic materials through the smelting approach using the relevant ores. So, metals like iron, copper, lead, zinc and silver were produced in the early stages through the smelting approach. Then the craftsmanship with the natural materials were used to make the products, and then rudimentary casting methods were used to make the products. Okay. This was done in the early stages as far as the early stages of the material processing is concerned. Thereafter, industrial revolution induced the mechanization which led to the mass production techniques such as the metalworking involving like say the rolling, forging, extrusion etc., chemical processing for making the variety of polymers and making the related products, and the development of the newer steels and the polymers for variety of the new applications and enhanced performance of the component. Then modern advancement in the material processing includes like additive manufacturing. Additive manufacturing can be used for making the variety of products in smaller quantity, developing the nanomaterials for a wide range of the applications to deal with the challenges being faced by the society, and also for improving the performance of the component which are being used in engineering applications. Functionally graded materials to deal with the challenges, especially when handling the variety of materials and they are being used together, say dissimilar metal joining, and use of high entropy alloys for specific high temperature and hostile service conditions. So, these you can say the modern advancement as far as the material processing is concerned. You know, we have to deal with the variety of the materials in material processing, which includes metals, ceramics, polymers and then composites combining these materials. So, as far as the metals are concerned, these materials are obtained by extraction from the mineral ores, and then these are processed in form of slab, and these slabs are used as a starting material, which are further processed in form of plates, sheets, angles, girders, etc. The metals are usually characterized by high malleability so that they can be deformed easily, thermal and electrical conductivity, good strength and ductility, and because of these attractive characteristics, these are used in construction, automobile, aerospace and engineering industries. Variety of the metals are used, especially like variety of the steels, which includes like carbon steel, alloy steel, stainless steels, and lot of advanced steels nowadays we have aluminum alloys, magnesium alloys, copper alloys and the titanium and many other metals which are extensively used nowadays in these industries. Ceramics is the another important category of the material which is extensively used for making variety of the products. So, ceramics like metals, these are also obtained from the minerals ores, and then these are refined in form of chemical and powders. These are mostly ceramics are mostly non-metallic inorganic materials, and these offer very high hardness and very high resistance to the surface. Thermal softening means hot hardness is very high, they do not soften easily at high temperature, and also these are known for high brittleness. Okay. These are good under the compressive conditions although. So, these are commonly used for applications like pottery, electronics and in aerospace. Then polymers, the polymers, these the polymeric materials are obtained by processing of the crude oil, then processed in form of pellets as a starting material. So, these pellets are used for making the polymeric products using the various processing routes. Polymers are basically the long chain molecules that includes the plastics and rubber which are used for making a variety of the products. These can be semi crystalline or amorphous, and which in turn affects their the mechanical properties and the response to the thermal conditions or response to the heat. These are versatile in terms of the lightweight, ease of operation and electro economics. So, these are cheaper actually, these can be processed easily because of the low melting point, and of course, these are very light in weight, and therefore, these find extensive applications in electronics, automotives, furniture and in construction industry. Now, we have the fourth category, which is basically the hybridization of any of these materials, like we can have the metals or the ceramics or the polymeric materials are reinforced or introduced with the third kind of or with the another kind of the material to make the to obtain a unique material which is defined as or which is termed as a composite. So, composites are basically the man made materials obtained by combining two or more constituents to achieve the desired set of the properties. Okay. So, here we can have the matrix one material which is termed as matrix, which can be metal, which can be polymer or which can be ceramic, and then in the matrix we try to introduce the suitable constituents as per the requirement of the properties. Say for increasing the wear resistance we introduce the hard constituents. For increasing the electrical conductivity, we introduce particles which are having the good electrical conductivity like graphite powders. For increasing the lubrication characteristics, we try to introduce the molybdenum sulfide or the graphite in the metallic matrix. Likewise, to increase the strength of the polymers, lot of natural fibers are introduced to make the sustainable materials. Okay. So, depending upon the kind of the matrix materials, we have the metal matrix composites, ceramic matrix composites or polymer matrix composites. Okay. And when we introduce a reinforcing agent in a given matrix, then we try to obtain a set of properties which are not there in any of those constituents individually. So, because and in composites each constituent retains its identity, and that in turn helps in obtaining the contradicting properties such as hardness coupled with the toughness for improved performance, or and realizing the functionality of the material for unique applications like good toughness coupled with the electrical conductivity, good hardness coupled with the lubricating features, or good strength coupled with the electrical conductivity. So, composites help in realizing the properties which are difficult to achieve in a given one material. Okay. So, the contradicting properties can be realized by developing the composites. So, depending upon the reinforcing agent, we can have the metal matrix composites, ceramic matrix composites, and the polymer matrix composites, and these are various materials which are used as a matrix. Okay. So, metals and alloys like steels, aluminum, copper form the metal matrix composites, and ceramic materials and glasses like silica and carbide, alumina, titanium carbide, boron carbide, concrete glasses, etc., are the ceramic matrix composites, and the polymers like resins, rubbers, epoxies, thermoplastics, and foams are used as a matrix in case of the polymer matrix composites. Okay. So, now the material processing is concerned. Material processing involves the three stages. Like first it involves like see what is the starting material, like its condition, its properties, its composition. So, like study the starting material characteristics, and it may be required to do suitable alloying or refining in case of the same metal casting. It may be required to add the plasticizers or binders in case of the polymeric materials and in ceramic materials for the processing by injection molding or the powder metallurgy. So, under this what we try to see, study the material, starting material, and try to see if there is a need of any kind of the change in form of alloying, refining, degassing, fluxing, filtering, adding plasticizers, binders, or any other constituent that is needed to impart the desired characteristics in the component through the control of the microstructure of the product which is being made. Thereafter, we have the material processing operations, means the first it is the starting material. Once you have studied and given the desired characteristics to the starting material, it is processed. Okay. So, the processing can be done in three stages. One is the forming one, where in the forming basically the flow of material is involved, like say in case of metals, the flow of metal, flow of molten metal in casting, and flow of the metal in solid state in case of the forming. Flow of the polymers is involved in semi solid state, viscous polymers, and that is used in case of the molding to make the polymeric product, say injection molding and variety of the molding processes. Ceramics flow in case of the powder metallurgy, followed by, so the ceramic powders will be filled in the cavity and followed by the compaction. So, the flow in the forming, flow of the material is involved under the different kind of the process conditions, which may be heat, which may be pressure, or which may be normal gravity. Okay. Then depending upon the processing route which is being followed, whether it is just plastic deformation or molten metal is allowed to solidify in case of casting, or the polymer is allowed to solidify and cool down in case of the molding, and the compaction is done followed by heating for sintering purpose in case of the powder metallurgy. Okay. Additive processing are those where this is basically involves layer by layer approach for developing the 3D products. So, rapid prototyping, 3D printing, and additive manufacturing is another category of process which is used for making the product with the desired structural features, shape and properties so that it can perform during the service. Subtractive processes, basically from the given starting material, unwanted extra material is removed in form of chips so that the desired shape is realized, and this is typically known as the machining. And further, according to the starting material, material processing can be termed as the metal processing, ceramic processing and polymer processing. So, this is just the classification or grouping of the processing, material processing based on the starting material, whether it is the metal which is being processed. So, metal processing, ceramic is being processed for ceramic processing, or polymer is being processed for polymeric processing. Then this is the another way of looking at, where in primary shaping, where general shape is achieved in material processing through the casting and forming. Then secondary processing is used for achieving the desired dimensional accuracy and tolerance, or achieving the very large and complex shape, large size and very complex shape products. Then we can do the finishing processes using grinding or super finishing to achieve the desired degree of finish and the dimensional control. And property enhancement through the heat treatment, surface modification in terms of coatings, electroplating, burnishing and case hardening, lot of other property enhancement things can be done. Okay, now I will summarize this presentation. In this presentation, basically I have tried to give the overview of the material processing and the location of the material processing in entire product manufacturing cycle. What are the major stages of the material processing? What are the common materials which are used in material processing for making the engineering goods? Thank you for your attention.